to algebra maths. Today I want to be teaching on indices. Okay, I want to give you the secret on how to solve any question in indices. Okay, now indices. Now the word indices is a plural form of index. Singular, indices plural. So what is the meaning of index? It means power, or you can call it exponent. That's the meaning. So when we say indices, we are talking about power or exponent. Okay, follow me. If I a times a times a times a, this is the same as a raised to power 4. You see, instead of writing a in 4 places, I'll just write a raised to power 4. This a to the power 4, what does it mean? It means a in 4 places. So this my a is called the base, while this 4 that is up is called the index, or the power, or the exponent. Okay, this 4 is called the index. You can call it the power. You can also call it the what? The exponent. Now, let me give you the laws, 7 laws of indices. If you know these 7 laws, there's no question in WAC, in NECO, in UTME, and in post-UTME, you cannot solve 7 laws of indices. Let's go. For 1, if I raised to power m times a raised to power n, this is law 1. A power m times a raised to power n. If the base are the same, that's the first condition. The base must be the same. Remember, this a is symbolic. It can be a number. It can be a letter. The same with this m. The same with this a, and the same with this n. Look at what the first law is saying. If the base are the same, that's number 1. The number 2, multiplication sign is separating them. What you will do is this: pick one of this a, and we add the powers m plus n. Multiplication sign will turn to plus. That's what the law is saying. If the base are the same and multiplication sign is separating them, pick one of the base, the powers. If something like this, the base here are the same, I will pick one, and we have the powers 2 plus 4. So I will have 3 raised to power 6 as my answer. So this is the first law. If the base is the same, condition 1. Condition 2, multiplication sign is separating them. Take note of that. Meaning, if I have something like this, a raised to power m plus a raised to power. Okay, look at law 2. Law 2 is just like the first law. Okay, law 2 is just like law 1. This is the law. If I have a raised to power m divide a raised to power n. If I have a raised to power m divide a raised to power n, the base here are the same. I will pick one a. Okay, then my division sign will turn to subtraction. I will subtract the powers m minus n. Okay, that's what the law is saying. For you to apply this law, it must satisfy these 2 conditions. 1, the 2 base must be the same. That's number 1. Then number 2, there must be division sign here for it to turn to negative sign. Meaning, if I have something like this, a raised to power n minus a raised to power n, if I have something like this, there is no way I can apply indices law. Even though the 2 bases here are the same, but what I have is subtraction sign, not division sign. So I cannot apply the law of indices here. Take note of that. Okay, law 3. For law 3, I have a raised to power m or bracket n. A raised to power m or bracket n. This is a power. This is another power. Power and power. We can multiply the 2. We can multiply these 2. And we have a raised to power m times n, which is a raised to power n. That's what the law is saying. If you have a to the power of n or bracket to the power of n, you can multiply these two, you have this. Take for instance, I have 3 raised to power 2 or bracket 3. 3 raised to power 2 or bracket 3. This is a power, this is another power. I can multiply these two. I will have 3 raised to power 2 times 3, which is 3 raised to power 6. That will be my answer. Okay, this is law 3. Now law 4. Okay, for law 4, a raised to power 0. A raised to power 0 is 1. Anything to the power of 0 is 1. You don't need to solve it at all. Just put 1 there. Anything to the power of 0 is 1. Let me prove it. How? A raised to power 0 is 1. How? Look at it. A raised to power 0. A raised to power 0 is the same thing as a raised to power. Let me turn this 0 to b minus b. This and this, they are the same thing. Okay, b minus b will give me this back 0. Okay, now this is the same thing as a raised to power b divided a raised to power b. Yes, that law 2 of indices I gave you. The same base, you pick one, then you subtract the powers, b minus b. Okay, now this a raised to power b divided a raised to power b is the same thing as a raised to power b over a raised to power b. This division sign is the same as this. So these two can go, you get 1. So that's the proof that a raised to power 0 is 1. That's the proof that anything to the power of 0 is 1. So if I have something like this, 2 a raised to power 5 times 3 a raised to power 6 over 4 a raised to power 7, or in bracket to the power of 0. If I have something like this, I don't need to solve. I don't need to solve. I'll just put 1 there. Why? Because everything here to the power of 0, and anything to the power of 0 is what? Is 1. Okay, so this is my law 4. Then my law 5. So this is my law 5. If I have a raised to power minus n, negative index law, if there's negative sign in the power, this will give me 1 over everything here, excluding the negative sign. I will write it down. E raised to power n. That's all. If you have negative sign at the power, 1 over, then everything here, bring it down. E.g., imagine I have 3 raised to power minus 2. Because there's a negative sign here, I will write 1 over. Then everything here, excluding the negative sign, I will write it down. 3 raised to power 2. I don't need to write this negative sign again. Is this negative sign that has turned to 1 over? So finally, this will give me what? 1 over 3 to power 2, which is 3 times 3. That will give me 9. So this is law 5. Anything when you have a negative sign at the index, it means 1 over everything down. Okay, now law 6. Law 6. For law 6 is fractional index law. If I have a raised to power n over n, this is a fraction now. This is the numerator. This is the denominator. Okay, so if I have fraction at the power, this is what the law is saying. The denominator will form the root of a or bracket m. The denominator will form the root of the base, which is a, or to the bracket of the numerator, which is m. Meaning, if I have a over 2 over 3, these 3 will form the root of this 8 or to the bracket of 2. That's what this law is saying. The denominator, these 3, will form the root of this 8, which is the cube root of 8 or to the bracket of the numerator, which is 2. Of course, you can solve with this. The cube root of 8 is 2, or bracket 2. 2 in 2 places is what? 2 times 2, which is what? 4. So this is law 6 fractional index law. Denominator form the root of the base onto the bracket of the numerator, which is m. Alright, then the last law, which is law 7. If I have a raised to power m equals to a raised to power n, the two bases are the same. And equality sign is what is separating them. This and this can go, just pick the powers, n equals to n. That's all. If the two bases are the same, equality sign is what is separating them. Equate, then pick the powers. Meaning, if I have something like this, 3 raised to power s equals to 3 raised to power 2, these two can go, I'll pick the powers, s equals to 2. So with these 7 laws I've given you, there is no question in NECO, in WAEC, in UTME, post-UTME, A-level, any question at all in indices. If you apply these 7 laws correctly, you will get your answer. Now let me pick some questions at random from WAEC, NECO, JAMB, and post-UTME. I will apply this law. You will discover that I'll be getting my answers. Let's try it. Let's go.